Hi, this is mathematics class for 12th standard by Senthil XII. Next question in this inverse, f function from r plus 2 4 to infinity. What is mean by r plus 2 4 to infinity? This domain contains r plus positive values and then codomain contains 4 to infinity, given by the function f of x is equal to the function given function is x square plus 4. We have to show that f is invertible with the inverse f inverse of f is given by, this is the inverse we have to prove. Okay, so how can we prove that f is invertible? That is nothing but the function is 1 1 and on 2 we have to prove, correct? So f of x is equal to what they given, x square plus 4. So that I am taking that let f of x1 is equal to f of x2, that is x1 square plus 4 is equal to, suppose if it is x2, if you are substituting means x2 square plus 4, these two cancel, bring this side, x1 square minus x2 square equal to 0. So this can be written as x1 plus x2, x1 minus x2 is equal to 0, right? So individually we can equal to make it equal to 0, but this will not become 0 because see that x1 and x2 are greater than 0, right? x1 and x2 both are greater than 0. They given that r plus x value, that is domain contains only positive values, therefore x1 plus x2 not equal to 0, x1 plus x2 not equal to 0, therefore only possibility is x1 minus x2 is equal to 0. This implies x1 equal to x2. So what is the condition? F of x1 equal to f of x2 means x1 equal to x2. Therefore what we can say, f is 1 1 function. So if we prove onto function means that's all over. 1 1 and onto means f is invertible. So the next one is onto function we have to prove. The given function I am taking as y is equal to x square plus 4. From this we have to find the value of x, that is x square is equal to y minus 4, then x is equal to square root of y minus 4. So this is nothing but y value takes greater than 4, right? So y value is nothing but more than 4. So definitely this value is greater than 0. So therefore what we can say, for all values of y, that is belongs to 4 comma infinity, there exists x belongs to r plus. Therefore what we can say, f is on 2. And what is that inverse? This is the inverse of that function. Therefore 1 1 and on 2, therefore what we can say, f is invertible. Actually this is the inverse function, invertible. And also f inverse of y is equal to this function. Actually x means nothing but f inverse of y is equal to square root of y minus 4. That we can write in terms of x also. Change the variable, both sides you change the variable. So f inverse of x is equal to square root of x minus 4. Actually this is the inverse function. F of x is equal to x square plus 4. That inverse function is f inverse is equal to square root of x minus 4. So like this we can find the inverse. So first one, invertible means 1 1 and on 2 we have to prove. Both is there means we can say it is invertible. Then here I said for this statement, for all values of y belongs to 4 to infinity, there exists x belongs to r plus. This is x, it is nothing but r plus. Here it is y, that is nothing but 4 to infinity. This is r plus, positive values. Okay. So for all values of y, that is in this codomain, each and every values elements, there exists an x here. That means for each and element in this codomain, there exists a pre-image in this set. That is the meaning. Pre-image is there, so that what we can say, it is onto. That's why I am telling that f is onto. Clear? Consider one more question from your exercise 1.3. F function r plus 2 minus 5 to infinity, that is f of x is equal to 9x square plus 6x minus 5. This is the function, so we have to prove that this is invertible and we have to find the inverse of this function. So f of x is equal to 9x square plus 6x minus 5. This is the function. So to prove one function, or to check whether it is one function, first I am taking, let f of x1 is equal to f of x2. Okay, this is f of x function. I am taking f of x1 is equal to f of x2. So what I will get, 9x1 square plus 6x1 minus 5 is equal to 9x2 square plus 6x2 minus 5. Both sides minus 5 we can cancel. Bring this side, 9x1 square minus 9x2 square plus 6x1 minus 6x2 is equal to 0. Here if you take 9 outside, what you will get, x1 square minus x2 square. Here you take 6 outside, means x1 minus x2 is equal to 0. Actually this is a square minus b square formula, so a plus b into a minus b, so x1 minus x2 will come, right? That x1 minus x2 I am taking outside. This and from this and this as common I am taking out. So what will be the remaining here? 9 into x1 plus x2. Are you clear here? Actually this is in the form of a square minus b square, so a plus b into a minus b. A plus b is here, a minus b I am taking outside. Here only plus 6, because this term I took out. Okay, now see here also AB is equal to 0, right? If AB is equal to 0, either A is equal to 0 or B is equal to 0, any one, right? So here which one becomes 0? This only becomes 0, because 9 into x1 plus x2 plus 6. So x1 and x2 are, see here, are plus. Both are positive, so that this will never becomes 0 as like before problem. So x1 minus x2 is equal to 0, because 9 into x1 plus x2 plus 6 not equal to 0. This will not become 0. Therefore what I am taking, x1 minus x2 is equal to 0. Therefore x1 is equal to x2 we can say. Therefore what we can say, f is one function. Next, for onto, let this function f of x becomes y. Y is equal to 9x square plus 6x minus 5. From this we have to find the value of x. Actually here x square is there, x is there, so that directly we cannot bring this side. So what I am doing, we have to change this as whole square format. We already completed in 10th standard. We studied the square completion method, right? So by using that method, 9x square can be written as 3x the whole square plus 6x. I am writing like this, 2 into 3x into 1. So here a square plus 2ab plus b square we need. So plus 1 square minus 1 square minus 5. That is, this term we are writing like this, square completion method. 9x square I am writing 3x square my plus 2ab format. This 6x I am writing plus 2ab format plus b square form we need, so that plus 1 square I am writing. For balancing this, minus 1 I am writing, so minus 5 is there. So this can be written as, this first three terms can be written as a plus b the whole square formula. So a plus b the whole square, the remaining is minus 6, which is equal to y. So 3x plus 1 the whole square can be written as y plus 6, right? This minus x come this side means plus 6. Next 3x plus 1 is equal to square root of y plus 6. So x is equal to what you will get, square root of y plus 6 minus 1 divided by 3. This is x value. That means for all y value, that is like last problem, for all y belongs to minus 5 to infinity, there exists x which belongs to r plus. Therefore what we can say, f is onto. So this implies f is invertible, and this is nothing but f inverse of y, that is equal to square root of y plus 6 minus 1 whole divided by 3. This we can change as f inverse of x is equal to square root of x plus 6 minus 1 whole divided by 3. Just to change the variable, f inverse of y is equal to, in terms of square root of y plus 6 minus 1 divided by 3, change the variable x, y here, change it as x. So x plus 6 divided by minus 1 divided by 3. This is the inverse of the function, given function f of x, that is equal to 9x square plus 6 minus 5. So this is the way to find inverse of the given function. One more method also you can prove f is invertible. What is that method? That method also I explain. F over g and g over f, both you find. F over g is equal to iy and g over f is equal to ix, means then we can say that f is invertible. Like that also we can find. So that is one method, this is another method. Okay, so which one is easy for you? You just try this. So both we can say it is invertible, and then we have to prove that this is inverse of the function. That's all.